Hey everyone, welcome to this full paper walkthrough for ENGAA 2019 Section 1b. This is our second in our series of the 2019 papers, 20 questions, approximately 35 minutes. And yeah, let's get straight into it. So for question 21, you're best off trying to draw the lines on a graph to work out the rough shape of the area you're trying to calculate. In this question, it turns out to be a trapezium, and you can work out the intersection points of the lines to get the required lengths for the trapezium before plugging these lengths into the equation for the area of a trapezium, which is half a plus b times height, which gives you the area of 21, which is C. For question 22, you're given the output power, and you can divide this by the efficiency of 90% to get the input power, which is 2000 megawatts. In 1 minute, this means that the energy inputted is 2000 times 10 to the 6 times 60. And this all comes from the GPE store of the water that's passing through the turbines. So you can equate the GP of the water, which is rho GH times volume, to the input power, which is 2000 megawatts times 60 seconds. And you can rearrange this to find the volume of water passing through in 1 minute as 80,000 meters cubed. For question 23, you'd first work out the derivative dy by dx, which is 3x squared plus 2px plus q. And because when x is equal to -1 and x is equal to 3, you have a local maximum and a local minimum. These are both stationary points, so dy by dx is equal to 0. You can then plug in the values for x is equal to -1 and x is equal to 3 to get two equations in terms of p and q. And you can finally solve these two equations simultaneously to give you the value for p. So question 24 is a typical conservation of momentum question, and it always helps to draw a diagram where you write down the speeds before and after. In this case, you don't know the speed after for p, so you can just give it a variable like x. And when you go through conservation of momentum, so total momentum before equals total momentum after, you end up with the speed of x after the collision as 25 meters per second. You're then asked to work out the force on car Q, and force from Newton's second law is the rate of change of momentum. The change of momentum is mass times change in velocity, which is 500 times 10, and the time over which the collision occurs is 0.2 seconds. So that comes out to be 25,000 newtons. For question 25, it's easiest to approach this question by first expanding 1 minus the square root of 2 all cubed, and then working to rationalize the denominator from there. So when you cube the whole thing, you end up with 7 minus 5 root 2 using the cubic expansion. And then you can multiply this by 7 plus 5 root 2 over 7 plus 5 root 2 to rationalize the denominator and give you minus 7 minus 5 root 2. And b is therefore minus 5. For question 26, resistance is resistivity times length over cross-sectional area, and you know V is equal to IR, so the potential difference across the wire is I times rho L over A, and when you work that out, it comes out to 0.8 volts, which is C. So question 27 requires quite a bit of trig manipulation, and you can start off by writing tan x sin x as sin squared x over cos x. And you can divide both sides of the equation by cos x to give you 7 plus tan squared x is equal to 5 sec x. Now, tan squared x is equal to sec squared x minus 1. So you can rearrange that to get sec squared x minus 5 sec x plus 6 is equal to 0, which is a hidden quadratic, and gives you the values sec x is 2 or sec x is 3. You can then plug that back into the equation 1 plus tan squared x equals sec squared x to work out the two values for tan x, which in this case are root 3 and 2 root 2. Question 28 is a pretty standard moments question. So what you want to do is, you know where the normal reaction force from the supporting rod is acting, and the only other force acting is the weight of the trapdoor itself. So you can take moments about the hinge to work out the value of the normal reaction force, bearing in mind that moment is force times perpendicular distance. So you want to take 0.4 cos 30 as the distance from the hinge for where the weight of the trapdoor acts. You can then solve this equation to give the normal reaction force as 40 root 3. So for question 29, you're given an equilateral triangle inside a circle and you're asked to work out the shaded area. So the first thing you want to do is work out the area of the triangle. You know that the side lengths are 8 and the angle at one corner is 60 degrees. So the area is half AB sine C, which comes out to 16 root 3. You can then use the cosine rule to work out the radius of the circle. So a squared is equal to b squared plus c squared minus 2bc cos a. And this gives you a value for the radius of 8 root 3. The shaded area is then just the area of the circle, pi r squared, minus the area of the triangle, which comes out to 64 pi over 3 minus 16 root 3. And with a bit of manipulation, you can see that this is E. For question 30, it's useful to remember the equation that phase difference in degrees is equal to 360 over the wavelength times the path difference delta x. You can use Pythagoras' theorem to work out the path difference between the two loudspeakers, which comes out to 50 centimeters minus 40 centimeters, which is 10 centimeters. You can then plug this value into the equation for phase difference, remembering that wavelength is wave speed 320 over frequency 400. And you end up with a phase difference of 45 degrees. For question 31, you want to manipulate the equation to get it into a hidden quadratic form, which you can then solve. So 5 to the 2x plus 1 is 5 times 5 to the 2x. So you end up with 15 times 5 to the 2x minus 5 to the x minus 2 is equal to 0. And you can write 5 to the x as a variable v. So you get a quadratic in the form 15v squared minus v minus 2 is equal to 0. Now v is either 2 over 5 or minus a third. And you know that for a real solution, 5 to the x must be positive. So 5 to the x must be 2/5, which means that x must be log base 5 of 2/5. Question 32 is a simple energy conversion question. You're converting the KE of the ball to GPE. The only thing to bear in mind is when GPE equals mgh, G in this case is 1.6. And you can then rearrange the equation to get the height that the ball gets to as 2,000 meters. Question 33 is quite hard if you've never done a problem like this before. So the first thing to do is you're given 3 separate integrals, and you can write a algebraic variable for each one using x, y, and z, and come up with simultaneous equations to solve for y in this case. So you end up with 2x plus y equals 4 from the first equation, and 5x minus z equals 7. But if you look at z carefully, z is just the sum of x and y, the integral from minus 2 to 2, and then the integral from 2 to 4. So you end up with 2 simultaneous equations, which you can solve, giving the value for x as 11 over 6. And if you plug this into 2x plus y is equal to 4, you get the value for y as a third. So for question 34, you're given an IV graph, and you know that R parallel must be the one with the steeper gradient because it has a lower overall resistance than the 300 ohm resistor by itself. You can work out the total parallel resistance by dividing 6 volts by 30 milliamps, which gives you a resistance of 200 ohms. And then you can use the formula for working out resistances in parallel to give you the value of the unknown resistance R as 600 ohms. For question 35, you're asked to work out the coefficient of the x to the 4 term. And to work this out, you need to first work out the coefficient of the t cubed term, which then integrates to give the x to the 4 term. So the coefficient of the t cubed term is 7c3 times 3 to the 4 times 2 cubed by the binomial expansion. And this comes up as 35 times 81 times 8. You then divide this by 4 the same way when you're integrating, add 1 to the power and divide by the new power to give the coefficient of x to the 4 as 5670, which is E. The formula for working out strain energy in a wire is half Fx, and you want to get this into a form that only uses the parameters given in the question. So to do this, you can take the equation for Young modulus, which is stress over strain, F over A divided by X over L, and rearrange it to give X is equal to FL over AE. When you then plug this into the energy equation, you end up with energy is F over 2 times FL over AE. And then you can plug in the values from the question itself to give you a strain energy of 8 times 10 to the minus 3 joules. For question 37, you're given two equations in terms of alpha and beta, and what you want to do is solve these simultaneously to work out the values of alpha and beta, and then subtract this from 180 for the total angle in a triangle to give you the value of theta. So you can write tan alpha as x and sine beta as y, and you end up with alpha being 45 degrees and beta being 30 degrees. When you subtract this from 180, you end up with theta as 105 degrees. So question 38 is a pretty tricky refraction question. You want to start off with the equation n1 sine theta 1 equals n2 sine theta 2, with n1 being the refractive index of the liquid, theta 1 being 90 minus alpha because you want to use the angle to the normal, not to the surface, and theta 2 being 90, which gives you n1 cos alpha equals 1. For the second part of the question, you're using the same equation, but now the ray is coming from the air and going into the liquid. So you end up with 1 sine 90 minus alpha is equal to n1 sine 90 minus beta. Again, remembering that you want the angle to the normal, not to the surface. That's why we're subtracting the angle from 90. You can then rearrange this equation, also using the value from the first part, n1 cos alpha equals 1, to give you the relationship that cos beta is equal to cos squared alpha. So for any sort of quartic or cubic inequalities question, you first want to work out the solutions to the equations. You want to work out where the curve crosses the line y is equal to 0. Now to find the solutions for this equation, you're not given any explicit values, but you can use the factor theorem to work out that f of minus 1 equals 0, so x plus 1 is a factor. And then you can rearrange and compare coefficients to get your solutions as x is equal to minus 1, which is repeated, and x is equal to 4. You can then draw a rough sketch of the curve showing the repeated root at x is equal to minus 1 and crossing the x-axis at x is equal to 4 to find that the curve is above the line y is equal to 0 only when x is greater than 4. So this is question 40, which is the last question on the test, and it's easiest to start off by drawing a free body diagram, which you can use to conclude that force, the normal contact force minus the weight of the person is equal to ma from Newton's second law. You can work out the acceleration using the gradient of the velocity time graph, which comes out as 0 minus 2 over 5, which gives you the force as 800 minus 32, which is 768 newtons. Thank you for watching, everyone. Hope you found it useful. And for more ESAT practice and preparation resources, make sure to check out our website. Link will be in the description.